The National Electrical Code, or NEC, interpretation of attended and unattended receptacles can be subjective, which leads to differing opinions among inspectors. An interpretation supports the need for a bubble cover in damp locations, such as those under eaves, and a weatherproof cover in wet locations, such as those under windows. However, NEC Section 406.8b allows for a weatherproof cover if the attachment cord is not plugged in. This provision seems to contradict the requirement for a bubble cover in wet locations, even if the cord is not plugged in. Some inspectors take a strict approach and require bubble covers on all outdoor receptacles, regardless of location. Others allow weatherproof covers if the cord is not plugged in. A concern is that contractors may install bubble covers for inspections and then switch to weatherproof covers once the home is complete, compromising safety. To address this issue, it has been suggested that the NEC consider removing the phrase beating rain or water runoff from Section 406.8 and defining attended and unattended based on a potential time frame that an attachment cord may remain plugged in. This would provide a more objective criterion for determining the need for a bubble cover. The interpretation of attended and unattended receptacle locations in the NEC can be challenging due to differing opinions among inspectors and perceived contradictions in the code. A clearer definition in the NEC based on a time frame for potential cord usage could help resolve this issue and ensure consistency in inspections. Ultimately, the goal is to ensure electrical safety while also considering the practical aspects of installation and aesthetics. The NEC aims to provide a framework for safe electrical installations, but its interpretation can sometimes be open to debate. Firstly, understanding the specific requirements for outdoor receptacles is crucial. Secondly, it's important to consider the potential for water exposure in different locations. Thirdly, it is important to keep in mind that inspectors' interpretations may vary. A clearer definition of attended and unattended could help to bridge these gaps and ensure that installations meet the intended safety standards. In wet locations, which are subject to direct exposure to weather, bubble covers are typically required to provide protection against rain and moisture when an attachment cord is plugged in. However, when the receptacle is not in use and the cord is unplugged, a weatherproof cover may be sufficient according to certain interpretations of the code. Damp locations, on the other hand, are generally considered to be areas that are sheltered from direct exposure to weather but may still be subject to moisture. In these locations, the requirements for receptacle covers may be less stringent, depending on the specific interpretation of the code and the inspector's discretion. The potential for contractors to switch out bubble covers for weatherproof covers after inspections raises concerns about compromising safety. This practice could undermine the intended protection against water exposure, particularly in wet locations where bubble covers are specifically required when the receptacle is in use. A more objective criterion for determining the need for a bubble cover, based on the potential time frame that an attachment cord may remain plugged in, could help to address this issue. This approach would provide a clearer and more consistent standard for ensuring electrical safety in outdoor receptacle installations. The suggested change to the NEC, which involves removing the phrase beating rain or water runoff from Section 406.8 and defining attended and unattended based on the potential time frame that an attachment cord may remain plugged in, aims to provide a more objective and consistent standard for determining the need for a bubble cover. By focusing on the potential duration of cord usage, this approach would help to clarify the requirements for outdoor receptacle installations and reduce the subjectivity in code interpretation. It's important to note that the NEC is a living document that is regularly updated and revised to reflect changes in technology, safety standards, and industry practices. The process of updating the NEC involves input from a wide range of stakeholders, including electrical engineers, contractors, inspectors, manufacturers, and consumer groups. These stakeholders work together to identify areas where the code can be improved and to develop provisions that will enhance electrical safety. The NEC is typically updated every 3 years, and each new edition incorporates the latest changes and revisions. This ensures that the code remains current and relevant to the evolving needs of the electrical industry. Electrical inspectors play a crucial role in ensuring compliance with the NEC and enforcing safety standards. Inspectors are responsible for reviewing electrical plans, conducting site inspections, and verifying that installations meet the requirements of the code. They have the authority to approve or reject installations based on their interpretation of the code and their assessment of the safety risks involved. Because inspectors' interpretations may vary, it's important for electrical contractors to be familiar with the specific requirements and expectations of the local inspection authority. This can help to avoid misunderstandings and ensure that installations are approved without unnecessary delays. In addition to the NEC, many states and local jurisdictions have their own electrical codes and regulations that may supplement or amend the NEC. It's important for electrical contractors to be aware of and comply with all applicable codes and regulations in the areas where they work. These codes and regulations may address specific issues or concerns that are unique to the local environment, such as weather conditions, soil types, or building construction practices. Compliance with all applicable codes and regulations is essential for ensuring electrical safety and protecting the public. The NEC provides minimum standards for electrical installations, but it's always a good idea to go above and beyond these standards whenever possible to enhance safety and reliability. This may involve using higher quality materials, providing additional protection against water or other hazards, or implementing more robust grounding and bonding systems. By taking a proactive approach to safety, electrical contractors can help to prevent accidents and injuries and ensure that electrical systems operate safely and reliably for many years to come. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock hazards. Bonding connects all metal parts of an electrical system together, which helps to equalize voltage potentials and reduce the risk of electric shock. The NEC has specific requirements for grounding and bonding, and it's important for electrical contractors to follow these requirements carefully to ensure that electrical systems are properly grounded and bonded. Regular maintenance and inspection of electrical systems are also essential for ensuring safety. Over time, electrical components can deteriorate or become damaged, which can increase the risk of electrical hazards. Regular inspections can help to identify potential problems before they lead to accidents or injuries. Maintenance tasks such as tightening connections, replacing worn-out components, and cleaning equipment can help to keep electrical systems operating safely and reliably. It's important for homeowners and building owners to have their electrical systems inspected regularly by a qualified electrician. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents and injuries. Homeowners and building owners should be aware of potential electrical hazards and take steps to minimize the risks. Electrical contractors should follow safe work practices and comply with all applicable codes and regulations. The electrical inspectors should enforce safety standards and ensure that installations meet the requirements of the code. By working together, we can create a safer electrical environment for everyone. Furthermore, the use of ground fault circuit interrupters, or GFCIs, is an important safety measure, especially in areas where there is a risk of water exposure. GFCIs are designed to detect small imbalances in electrical current and quickly shut off the power, which can prevent electric shock. The NEC requires GFCIs in many locations, including bathrooms, kitchens, and outdoor areas. It's important to test GFCIs regularly to ensure that they are functioning properly. Surge protection is another important consideration, especially for sensitive electronic equipment. Power surges can damage or destroy electronic devices, and surge protectors can help to protect against these surges. Surge protectors are available in a variety of types, including whole-house surge protectors and plug-in surge protectors. It's important to choose surge protectors that are appropriate for the equipment being protected. Arc fault circuit interrupters, or FSIs, are designed to detect arc faults, which are a common cause of electrical fires. FSIs can help to prevent fires by quickly shutting off the power when an arc fault is detected. The NEC requires FSIs in many locations, including bedrooms and living rooms. It's important to understand the difference between GFCIs and FCIs and to use the appropriate type of protection in each location. Electrical safety training is essential for anyone who works with electricity. Electrical workers should receive thorough training in safe work practices, including lockout/tagout procedures, personal protective equipment, and hazard awareness. Training should be ongoing and updated regularly to reflect changes in technology and safety standards. It's also important for homeowners and building owners to receive basic electrical safety training. This training can help them to identify potential hazards and take steps to minimize the risks. In addition to the technical aspects of electrical safety, it's also important to consider the human factors. Human error is a common cause of electrical accidents, and it's important to address the factors that contribute to human error, such as fatigue, stress, and distractions. Creating a culture of safety is essential for preventing electrical accidents. This involves promoting open communication, encouraging employees to report hazards, and recognizing and rewarding safe behavior. By fostering a culture of safety, organizations can reduce the risk of electrical accidents and injuries. The NEC provides a comprehensive set of standards for electrical installations, but it's important to remember that the code is not a substitute for good judgment and common sense. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. If you're not sure how to do something safely, it's always best to consult with a qualified electrician. Electrical safety is everyone's responsibility, and by working together, we can create a safer electrical environment for all. The interpretation of attended and unattended receptacle locations, as described previously, is indeed a nuanced issue within the electrical industry. The heart of the matter lies in the subjective nature of the terms and how they relate to the practical application of electrical codes, specifically the NEC. Let's further explore this topic, diving into the different facets of the debate and potential solutions. The ambiguity stems from the lack of a concrete definition for attended and unattended within the NEC itself. This lack of clarity allows for varying interpretations among electrical inspectors, leading to inconsistencies in enforcement. Some inspectors may adopt a stricter interpretation, requiring weatherproof bubble covers for all outdoor receptacles, regardless of their location or intended use. This approach errs on the side of caution, prioritizing safety above all else. Others may be more lenient, allowing for standard weatherproof covers in certain situations, particularly if the receptacle is not expected to be used frequently or if it is located in a relatively sheltered area. This difference in interpretation can create confusion and frustration for electrical contractors who must navigate the varying expectations of different inspectors. It also raises concerns about the potential for inconsistent levels of safety across different installations. The suggestion to remove the phrase beating rain or water runoff from section 406.8 of the NEC is an attempt to address this ambiguity and create a more objective standard. The rationale behind this suggestion is that the presence of beating rain or water runoff can be difficult to quantify, leading to subjective judgment about whether a particular location qualifies as a wet location requiring a bubble cover. By focusing instead on the potential time frame that an attachment cord may remain plugged in, the code could provide a clearer and more consistent basis for determining the appropriate type of receptacle cover. For example, if a receptacle is intended for continuous use with an appliance or tool that remains plugged in for extended periods, a bubble cover would be required to provide continuous protection against moisture. Conversely, if a receptacle is only used occasionally and the cord is typically unplugged when not in use, a standard weatherproof cover may be deemed sufficient. This approach would shift the focus from the physical environment to the intended use of the receptacle, providing a more practical, unpredictable standard for compliance. However, it's important to note that this is just one potential solution, and there may be other ways to address the ambiguity surrounding attended and unattended receptacle locations. The NEC is a constantly evolving document, and the process of revising and updating the code involves input from a wide range of stakeholders, including electrical engineers, contractors, inspectors, manufacturers, and consumer groups. These stakeholders work together to identify areas where the code can be improved and to develop revisions that will enhance electrical safety. It is also worth noting that the cost factor plays a role in the decisions made by homeowners and contractors. While bubble covers offer superior protection against the elements, they are often more expensive and less aesthetically pleasing than standard weatherproof covers. This can create a temptation to opt for the cheaper and more attractive option, even if it means compromising on safety. To address this issue, it may be necessary to educate homeowners and contractors about the importance of using the appropriate type of receptacle cover and the potential consequences of using a substandard cover. In addition to the technical requirements of the NEC, it's also important to consider the practical aspects of electrical installations. For example, the location of a receptacle may affect its exposure to the elements. A receptacle that is located under a deep eave may be relatively sheltered from rain and snow, while a receptacle that is located on an exposed wall may be more vulnerable. The type of building construction can also affect the exposure of receptacles to the elements. In some cases, receptacles may be recessed into the wall or protected by a weather-resistant enclosure. These factors should be taken into account when determining the appropriate type of receptacle cover. Ultimately, the goal is to ensure that electrical installations are safe and reliable, while also considering the practical and aesthetic aspects of the installation. This requires a collaborative approach between electrical engineers, contractors, inspectors, and homeowners. By working together, we can create a safer electrical environment for everyone.